Hey folks, Quill18 here, and welcome to a tutorial for how to create a first-person shooter very quickly using Unity 4 and also some Blender. This is the first Quill18 Creates tutorial that I'm going to do as part of a live stream, which is why I'm on screen here. And if you see me turning this way, it's because I'm watching the twitch.tv chat to see if anyone's got any questions. And we'll try to address them as much as possible, but what I'm going to do I'm going to build a section of the game and then take some questions and build some more of the game and take some questions and sort of go back and forth like that and cut up into parts. That way, if people don't want to see the question period, they can just skip over that and move right ahead. So the first thing we're going to do, well, I'll give you a quick little preview about the sort of thing I'm going for. I built a very simple two-room level here. If I hit play, then we can kind of wander around this level. Everything in here was just done very quickly just as a test, but we're going to get some shadows in here. All things we can do with the free version of Unity. Anything you see me do in here, you should be able to try at home at zero cost to yourself, including shadows. And a lot of people are going to be like, well, you can't do real-time shadows in Unity free version, but these are not real-time shadows. These are light mapped. They're very fast, even on things like iPads and whatever. And you can do them in the free version. So let us get started, and the first thing we have to do is create a new project. So we're going to call this, we're going to browse to the C drive, and then I like to stick it under sites, just my personal organization, and we will create a new folder called FPS Tutorial 2, I guess, because the other one was just my practice session. And we're going to create a new thing in there. We're not going to import anything, even though it actually works very well. If you want to import the character creator or character controller package that Unity provides, it has an excellent first-person controller in there. But we're going to write our own. The reason we're going to do that is so that we kind of understand a little bit more how it works. I think it's a good idea to sort of implement your own the first time, and then if you want to use the built-in Unity one, you can, because then you understand how it works and how you can modify it. But you know, it's really not that hard to do. There's actually not going to be a ton of programming required here to get us moving in this sort of first-person view. So now we have a new blank project in Unity, but before we actually start up in Unity, we're going to flip over to Blender and set ourselves up with a very basic level to walk around in. So Blender is a great open source free 3D modeling program, 3D renderer. It can do movies, it can do everything. It's an incredibly full-featured package. Basically, we're just going to use it to create our level geometry here, very simple level geometry. We may also create some actual objects in it after a little bit. But you can also use 3D Studio Max, Maya. There's so many different options that you can use for the 3D stuff. But I like Blender. It works great for me. It's free. It's wonderful. This is not going to be a Blender tutorial. I'm going to turn on the screencast keys so you can at least see what I'm clicking over here. But other than that, we're going to go a little bit fast on the Blender side. Snap cursor to center, get back over there. So I'm going to create very, very simple sort of like a 2D-ish dungeon-like level geometry, just because it's going to be sort of the fast way of doing it. But you'll see we can pretty much do whatever we want here. And there's many different techniques for how you can actually create these levels and how you're going to organize different blocks, and that's a whole other set of videos. So for now, I'm just going to add a plane. I'm going to start with an actual flat 2D plane. Right now it's 2 units by 2 units, and a unit in Unity usually treat it as a meter, or if you're American, about a yard. And obviously that's pretty small. We're gonna make it. I'm not sure what we're gonna make it. We're gonna make it maybe. Let's say I'm gonna increase it 25 times. We'll make it a 50 by 50 area. Then what I'm going to do is I'm going to subdivide it. Am I wrong in that there's a button over here for it? I usually just use, I usually just use the menus and things. We're going to cut it. So if you cut it once, you're getting sort of 2 sectors this way. I'm going to cut it 9 times. So I'm going to get a 10 by 10 grid. And then what I'm going to do is I'm going to switch to the face view. And I'm just going to grab some faces and extrude them downwards. So everything that gets extruded downwards becomes a room or a hallway, and everything that remains is basically a wall. So check this out. It's going to be very, very quick and easy way to do this sort of thing. So actually, what happens if I grab the ones on the edges? Okay, it does work properly. Good. So we're going to, let's call this our starting room. Let's make it a 3 by 3 room, like that, and then we'll have a hallway here connecting into another room that goes kind of this way, and then maybe we'll have like a little funny shaped room over here. We'll put a big room here, quite large, that goes like this, and make a hallway that maybe has a bend in it like that, and then something like this, like this. There's actually not going to be any room for another room over here. Maybe, you know what, we'll start up here in this sort of dead end. That'll work. And so now what I'm going to do is I'm just going to rotate the camera so you can see what's happening. I'm going to extrude along the z-axis, and I'm going to go downwards by, whoops, that's not right. Grab downwards, -4, boom. And if I switch to solid view, you can see we have kind of a little bit of a simple maze. It's not, you know, there's not a whole lot going on in here, but it's going to work, and it's going to work just fine for our purposes. Now, one thing you always want to be aware of when you're making these 3D models for games, let's switch from the solid mode to textured viewport shading. So everything looks fine from this angle, right? Looks solid. If I flip and go underneath, you can see that you're actually seeing through everything, especially if I drop out of edit mode. Everything looks fine from the top, although the shading is weird. It's solid, and from the bottom, everything is see-through. And that's the way it's supposed to be. The reason it works that way is that all of the polygons in here are one-sided. They're only rendered from one side, and from the other side, they're completely invisible. There's lots of explanations for why that is, performance reasons and things. It's fine and good, and it's the way that things should be. But if the polygons aren't turned the right way around, you get all this kind of unexpected behavior. Why can't I see this wall? So you can check it manually by going to the textures that way. That's one way of doing it. The other thing you can do is over here, you can pull this panel open by hitting N. You can have the normals be displayed on faces, for example. We'll set the size to 1. You can quite explicitly see all the blue lines, and they should be poking out in the direction that they're supposed to be visible in. So all the floor will all point up, the walls will all point in. And this is kind of unusual, because usually when you're modeling an object in the game, you're actually going to want all the normals pointing outside. Because, you know, it's like a solid crate or a person, right? A character walking around, you want all the normals pointing out so that they're solid looking. But if ever you've been in a game where you can get the camera kind of inside an object, and you've noticed that when you're inside an object you don't see it, you can see directly out, that's why, because the normals on the inside, or the faces on the inside, don't get rendered. If any of these end up being wrong, you can like select them all, and it's Control-N, but Control-N, the Make Normals Consistent button. If you hit that, it'll make them consistent. And by default, it makes them consistent on the outside, but if you flip them to the inside, in our situation, it's exactly what you want. So you can control it that way. You want to make sure that they're generally correct. The other thing I like to do that seems to work really well, just to make sure that the shading works well, is in the edit mode like this, I select everything, I tell it to smooth it, to shade it smooth. It won't be a problem on this map, but on some objects it can make a difference. You shade it smooth, and then it looks entirely wrong, but then with the object selected in object mode, you can add a modifier and set up an edge split, and then it tends to make everything work really, really well in Unity. The only thing I'm going to do is make it so that the floor is, there we go. So the floor itself is now at the 0 point of the screen. You can tell because of the red line. So the floor is at the origin, the ceilings go up. And this will be a perfectly fine level for us to initiate and run around in. We don't have a ceiling right now. We'll probably add one later, but for now I'm going to leave it as is. And oh, and I mentioned this in the pre-live stream chat. We're not going to be looking at texturing today. Texturing is a very sort of intricate and complex topic that we really have to look into a lot of things. It'd be very time consuming. We're just trying to go for speed here. So let's save this. We're going to go into our new tutorial assets. We're going to create a folder in here. Yes, create new directory called models. And we're going to call this, I mean, this is just our level, really. Let's call this our level 1 model. Save that. Then if we switch back to Unity, it'll take a tick as it imports this model. Grind, 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 grind. And now we have a models folder with our asset inside. Also, there's a default texture, a default material, sorry, applied to the to the model, and by default it imports that in when you import these in this way. I usually just leave the materials folder there. I leave that no name texture there, and I don't modify this material. Now you can assign all the materials and textures and all that inside of Unity if you want. You can have it so that inside of Blender if you want. So when you're in Blender here, you can have everything looking exactly the way it's supposed to in game, or you can apply the materials and textures just inside of Unity here instead. And I often work here, but that's mostly because I tend to work with simpler sort of. I think we got dropped. Did the stream get dropped? Apparently we did. So let me just restart that. Boom. Sorry to everyone watching on YouTube. So let me double check another thing here. Everything should be fine on my system. Maybe I'll edit this part out afterwards. And restart. There we go. All right, so we are still recording locally, we are still streaming, we're not dropping. It must have been a Twitch thing because it didn't drop a single frame over here from my side. So, streamers, I don't know what the last thing you just saw is. I'll repeat a little bit. Hopefully you saw me finish the model here. We saved it. We brought it into Unity. Well, we just switched back to Unity and it automatically picked up that the model was there. And we can change some of the ways that it pulls your model in. The most important thing we're going to do is turn on Generate Colliders. Okay, perfect. We're going to turn on Generate Colliders because right now the level is just visual geometry, right? So if we threw this into our level and then put some sort of physics-enabled object on it and just hit play on our simulation, the object would just fall right through the floor because the floor is just graphics. It's not physical. So we need to generate a mesh collider for our model and apply that. Now, if we put something like a ball on the in the level and dropped it, the ball would hit the floor and actually stay there. And when our character walks around, he's going to walk around on the surface. So if you're finding that things fall through, it's because of that. You want to click on your level. You want to click on Generate Colliders and hit Apply. If you do get weird stuff where the angles of your walls don't look quite right in Unity, you could use the Calculate Normals here, which is basically, whoops, I accidentally clicked on things. Stop clicking on things. The Generate Normals or Calculate Normals is the same thing basically as doing this edge split modifier. So I don't usually need to do it and everything works fine. So yeah, apply that because I misclicked a bunch of times. Other than that, everything should be exactly the way it's supposed to. So now if I take this model and drop it into our game world, we've got our thing. And again, you're not going to be able to see the walls when you're on the outside of it. So these walls are here. Here, you can't see them, and when I turn around, now they're there. So we have a very basic level. Everything seems to be the way that we want it. I thought there was one other thing I want to mention, but now I can't recall what that is. Oh, with the mesh collider. So you're going to be dropping balls on here, and they're gonna fall. They're gonna hit the floor, and everything's going to be good. And then one day you're going to bring in a model that is not. Doesn't have just like a sphere collider or a box collider or a capsule collider. It's going to have a mesh collider. You're going to make a model in Blender, bring it into here, and then you're bringing it into the game world, and you're going to turn on the physics, and it's going to fall right through the floor, and you're not going to understand why. It's because by default, mesh colliders can't really collide with other mesh colliders unless you turn on the, over here, you can turn on the convex thing. We're not going to deal with that in this particular video, but if you're finding that your mesh colliders are passing through one another, check out the documentation for convex and what it means. There's big implications, but that won't be an issue for this game. So we have a level. Now we just need a guy who can kind of walk around in it, right? So we are going to create we're going to start off by creating an empty game object which does nothing. We're going to make sure it starts off at the 0, 0, 0 point, although I just realized that that is going to kind of be inside of a wall. So where's our starting point? Oh, that's right. It's see, the problem with the lighting is it's totally flat. I can't see it from this angle. So before I continue, let me create a directional light just so we have something operating at kind of a vague angle. And no matter what, that's going to be flat. You know what? Instead of a directional light, let me drop one point light on top of here. Bring it up. Bring up the range. There we go. We're not going to keep that around, but this just means that we're actually getting a little bit of context for our actions while we figure it out. Okay, so we've created our empty game object here. We're going to put him in the start location, which, oh yeah, it's in this little cul-de-sac right over here. So it's just an empty. It doesn't do anything. It doesn't show up as anything. What do we need? Unlike, say, the pinball game, which I did during the last Ludum Dare, or the breakout game that I made previously on the Quill18 Creates channel, we can't just apply sort of regular physics to our character controller. The Unity documentation makes an excellent case of why this is, why your player character is not a true physics-enabled object. And the reason is that you have entirely different expectations when you play this game. When you hit forward on your keyboard, your guy's going to shoot forward at basically like 50 miles an hour suddenly, and as soon as you let go of the key, he's going to stop instantly. And if you turn your mouse and you're still going forward, your guy's going to turn at like a right angle and just keep going there. Objects don't move that way in reality. They have momentum, they have all these things, but that's not what we expect from our character controller. And indeed, that's what we're going to use, a special component called a character controller, which has collisions enabled, but isn't really a physics object whatsoever. And at least for me, it took me a long time to wrap my head around that when I got started. So, you know, hopefully you get it a little bit easier than I did at first. I'm very comfortable with it now. So our game object, we're going to rename this as player, first of all, because obviously we like to be very organized. We're going to go into components, physics. We're going to add a character controller component to our object. Now, it does a couple of things. It shows up a character controller here, and it does add a collision box to our object. It uses a capsule by default, but you'll notice that the capsule is centered on where our game object is. Now, I like having my player game objects be at the actual ground level of 0. Like, I like the game object to kind of be the guy's feet. That way, if I'm putting it on a surface, I know that I can make the y-coordinate equal to the height of the surface that I'm standing on, and everything will work out beautifully. I don't have to be like, well, my guy's 2 meters tall, so I guess I have to make him 1 meter above the ground for it to all work out. That's so awkward. So instead, what I like to do is in the character controller, I like to move the center of the character controller up. By default, the character controller has this height of 2 meters, sort of an averagey, sort of rounded off male height. So we're just going to move the character controller up by 1 meter. That way my player object can sit at 0 and everything will be fine. So his feet are just, you know, just barely over the ground. One thing is, I find there's every now and again you get in a situation where this collider box just hangs just slightly too low into the floor, or it might be, you know, at the exact same height, which is what's happening here. The 0 with the bottom of this capsule, that is exactly 0, which is where the floor is. And every now and again you get in a situation where the Unity physics engine considers it to be sticking through the floor, and you just fall through instead of sitting on it. So instead of actually setting it at exactly 1, I like to do something like 0.01, just round it off just slightly higher, and that'll ensure when the simulation starts, it'll just like settle onto the floor, and everything will work out exactly the way you want. The other modifiers in here you want to check the documentation for, but slope limit deals with how steep can a slope be with your character still climbing it? It defaults to 45, so anything steeper than this, your character is just, it's going to be effectively a wall, and anything less than that, your character is going to walk up like a ramp. There's also steps, which is literally like the height of a step that it can climb up and just keep counting. It's very, very handy. The character controller deals with a lot of sticky issues for you, like being able to go upstairs and go up ramps and not go up walls. So it's a very, very good thing. So we've got that. Great. It doesn't do anything yet, but that would be the next step. Let me swing over to the chat and answer a few questions before we go any further, make sure we haven't lost anyone. Some people are saying this is very complicated, and it is. The individual steps going on here are very simple. Individually, it's easy. It's like, oh, you just add a character controller to this. But it's knowing why you're adding it and all that. That puts a lot of difficult things, a lot of bigger questions. I don't see any specific questions so far. Can he jump? He will be able to jump. We're going to get to that. So by default, it doesn't. By default, the character controller is just sort of the physics rules of how we deal with collisions between the floor, with gravity, gravity-ish, and with slopes and things like that. It doesn't actually control your character. We're going to need a script for that, so that's going to be the next thing we throw in. I'm not going to answer any questions about Let's playing video games. That would be silly right now. That's not the topic. So let's go and start wiring up our guy to move around. Oh, the first thing actually we should do is talk about the camera. If this is a first-person game, then the whole deal with the first-person game is that the camera is sticking out of your character's face, basically. Oh, actually, let me backtrack one more step. Some people may be wondering, are we going to have a model for our character? And the answer is no, we don't need one. Since the camera is going out from us, we don't need an actual model for ourselves. And most of these games do exactly this. They might do something like a floating pair of arms in front of you that you see occasionally, and some games will take you to the next level to allow you, when you look down, to be able to see your feet, although I'm just thinking things like Mirror's Edge. Can't think of any other games where you can see your feet at this point. Obviously, things are different in a multiplayer game, but things are completely different in a multiplayer game. On your local client, you're still not going to have a model for yourself, but all remote players are going to be controlled by these sort of things. It's a whole different object, and we'll get into it later on if we need to. But we don't actually need a 3D model for ourselves here. Can you give him a gun? Sure, we can give him a gun. Again, there's a few different ways you can implement guns. You can literally just have it sort of floating in front of your character, and then when you're looking at it from the camera view, you're going to see the gun just fine. A lot of games actually do a second render pass for the gun, and I don't think we're going to get into that here. It's a little too complex, but we might stick some sort of gun in front of there just to see. So the camera we have to attach to our character, because when our character moves around, we want the camera to follow along with it. So we're going to take our camera, our main camera, and put it, there's a lot of different ways we can deal with this. We could attach a special script to the camera that makes it follow the player every frame. For our application, the simplest way to do it is simply to put the camera as a child of the player and just center it on the player's location, no rotation. And now if we take the player and move the player around, the camera will follow. However, right now it's currently sitting at the floor, so we're going to put it at maybe, let's call it 1.75 meters, like kind of eyeball height. We'll call that good enough. So now when we're looking out the camera, we're going to be looking out the player's eyes, and the camera is going to follow along with the player, including when we rotate around. So now we just have to get the player to move so that we can see what that's like. Actually, let me turn this guy around, because right now he's going to start the game facing into the wall. So let's turn the player 180 degrees so he's no longer doing that. Back him straight into the corner, and there we have it. So we're going to need a script. Let's create a folder for that just to keep ourselves organized. Scripts. I'm going to check for questions one more time before I continue. Crouch, lie down. I don't think we're going to do that in this game. I don't know what the best way to implement crouch lying down is. Probably literally just changing the height of the character controller and bring the camera down as well is the simplest way of doing it, right? Because by changing the height of the character controller's collision capsule, that will let you duck under obstacles. And obviously you just want to make sure that the camera also goes down so it looks like you crouch down to the player. Again, from the game's point of view, the game doesn't care where the camera is positioned. Right? You could leave the camera where it is, just shrink this down, you'd be able to walk through it just fine. It would just look really weird to the player. So we've got a script folder. So we're going to create a script. We're going to call it, very simply, we're going to call it first person controller. Can do just about anything. And because one of the things I always forget to do is I always forget to add the script to my objects. I'll program a big complex script, I'll hit play in the editor, and then I won't have any idea why nothing's working. And it's usually because I've forgotten to actually add the script to the player. So the first person controller is going to be responsible for taking keyboard inputs and moving our guy the way that it's supposed to do it. The default first-person controller that Unity comes with in the assets has multiple layers. It has multiple scripts involved, all working together to make it work together, including a script that's on the camera itself as opposed to your character. We're going to keep things very, very, very simple. As simple as possible, and then if we need added functionality, we can always break things out later on. But it's a good idea to not over-engineer things at the start.